Okay. So my name is Justice Kwame Apati, and I happen to be in the University of Ghana, and also professor of applied mathematics and computer science. And I mostly handle content in the field of numerical methods, machine learning, and data science. That's what I support the Department of Computer Science in training our students in those fields. Okay, so this will be the outline of our presentation, why we are here, some basic concepts in Matlab, how to plot some few things in Matlab, trying to understand the differences in scripts and functions, and how you'll be able to at least manage the tool, when to use it, and when to adapt, and proceed from there. Then we proceed to observe decision making, followed by loops, and finally, how do you get to us at the end of today's section? Just in case you want to reach us, get some few tips, some few clarity, how do you take it from there? These are some few, I think, 7 items I've listed here. And of course, they aren't exhaustive. So there's more you can search for yourself and proceed from there. As we all know, everything on earth evolves around numbers. And for a few of you who might have sat in the class of numerical methods, will find this content very useful. All because Octave and Matlab happens to be powerful when it comes to numerical computations. In most parts of Asia, you may come across Matlab as a fundamental tool in the industry, especially in engineering and applied sciences. One beautiful thing about Matlab is that it has a very comprehensive toolbox. Many think that Matlab is only for adding and plotting graphs alone. But it goes beyond that. The only issue is Matlab comes at a cost. So most often, you hardly see people using it. But you can get Matlab through your institution. If your institution cannot afford them, then you can go into Octave and proceed from there as well. Okay. Again, visualization and plotting. The big data guys, this is where you find yourself as well. If you design systems and you want to prototype them, this is where you are. And this is why you must be here to proceed from there, because it provides a platform for rapid development, and it becomes more prevalent in engineering and those who are into robotics. The last bar two is one of the tools that allows integration and interoperability, in the sense that if you have an idea about Python and you think the content in Matlab is too hard to apprehend and comprehend, you can just port a Python code into Matlab and continue from there. In those days, you have to do small in Matlab, small in R, small in Python, and then you keep going. But now you can import or you can port all the things you need from R, all the things you need in Python, in C++, in Java, through the Matlab interface or the console, and continue from there without moving out of Matlab. This is what makes Matlab interesting in today's world. And finally, simulations. Not all of us can afford devices to simulate systems. So Octave gives you a testbed to do that and make life easier for you. So rise from the lab to the industry. Can you imagine? Okay, I believe I've convinced you enough to understand why you must love Matlab or Octave in your research domain and space. The basic concepts in Matlab. Okay, So the first thing you and I want to pay attention to is nothing but the MATLAB environment. Before you learn any language, it's important to understand the environment you find yourself. There are some few things here, but again, it's good to observe what they are before we proceed. This is how the Matlab interface looks like if you are able to install them. If you're having 2020 and above, the interface pretty much look the same. And one key thing you observe is the command window where my mouse is hovering. And above here, you can see it written on the ribbon, command window. This is the first thing to pay attention to. And this is where you do all your testing, all your computations, they happen here. And that little guy you see here is called the prompt. The prompt. Now you know what you'll be doing and where you'll be typing your stuff. The next thing is whatever you are typing here is being recorded in a thing called the brain of MATLAB. So the brain of MATLAB is called the workspace. Whatever I do here appears in the workspace. So I can always pick them up and reuse them again. The only issue is that the workspace is volatile. The moment you lose your interface by shutting it down, all variables, all computations that find themselves in the workspace, unfortunately, get wiped off. But the beauty is that there's one more thing called the command history. The command history, which keeps track of all the things you've been doing for some time. It depends on how often you use MATLAB, but it can keep up to, I think, 12 kilobytes as a text file. So you can imagine how many things you'll be typing in there. Most students end up exhausting the 12 kilobytes sometimes in 2 years. It depends on how often you use MATLAB, and that determines how soon it fills up. However, in as much as there is a memory to keep all past records and history, it's good to know that that approach is also not efficient. So therefore, based on the time we have, we shall see how to document these things in a file for future use. Because you and I can't continue typing individual lines of code in the command window to test it. The last thing I'll talk about is the current folder, which is the current directory over here. The current folder. The current folder is where the files in which you are working with, the documents you are working with, the folders you are working with, this is where they end up displaying. And remember that if you intend to have a more persistent memory, then it's important to code your stuff in a file. And the file must be accessible in the current folder before you'll be able to run it. So therefore, since you all endeavor to write scripts, to write functions, then it's always important to learn how to organize your files. So how then do you organize our file? As part of our journey in the series, which I introduce you to how to understand version controls as well, and proceed from there. So you must always get a folder, name it as part of your project, after which make sure you are writing every single file into it. And when you are done, ensure that you are able to open it up in your current folder. My folder is called the IW Research, which is found in a folder called Matlab, where my mouse is. And Matlab is found in a folder called Documents. And Document is found in a folder called My Name. And my long name here is found in a folder called User. And the user is found in the roots. So you can always use the small buttons here to either open a file or go back to a file or move into the cloud and proceed from there as well. So now we have a fair idea about the environment in which you and I will be working in. There are more things over here we can observe, but we shall take them one at a time and proceed from there as well. It's good to learn to crawl than to rush to walk and falling without a balance. So let's kickstart to see what is next. So now we know all this and where to find them in the live application. Okay, so you proceed to look at some basic calculations. And that's what we shall be looking at. So addition, how do we add two things? How do you find exponents? Some field trigonometry, some complex numbers, some special constants, as well as some arithmetic operations. Okay, so we start. If I want to add two scalars, and of course it's basic, so we shall deal with scalars first and proceed to vectors and to matrices for the introductory section. And then going forward, we can now begin to look at a more localized version. For example, Matlab for numerical methods. For example, Matlab for differential equations. For example, Matlab for robotics. Matlab for data science. Matlab for bioinformatics. And again, those who are interested in those specific targets will now have to join, because if the foundation in those concepts are not too good, then you only join the pool to only listen. This is why we spend time today to go through the basic concept of Matlab. Okay, so how do we add two numbers? Quite trivial. Let me see if, okay, at least you're all online, so that's fine. So I can still keep my font this way and proceed. Pick a number, say 2, add it to, say 5. If you hit enter, you observe something interesting. It says ans equals 7. Ans equals 7. There's one thing to pay attention to in Matlab, and that is every single thing you do must be assigned to a variable. And Matlab have observed that you have failed to assign this to a variable. For that reason, it gave you a default variable called ans, which means answer equals 7. Now you shall observe very soon that once you do so, immediately the workspace recorded the variable ans equals 7. The danger here is that if I type 5, 3 plus 2, 3 plus 2, without again providing a variable, then all that I've done is to replace the ans back to 5. So now ans is called 5, or ans holds the number 5. So if I want to make use of this first ans, I've lost it, and I've lost it forever. This is why it's important to give names to your expression and proceed from there. Okay, now we have seen how to do additions. In the same way, subtraction, 3 minus 2, it gives you an answer. What if I want to find the exponent, so 3 to the power 2, with the caret symbol, 3 caret 2. In Python, you'll be doing star, 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 but here is 3 caret 2. That's exponentiation, 3 to the power 2. Okay, so now we've seen addition, we've seen exponentiation. We want to observe trigonometry. The SOHCAHTOA, the sine, cosine, tangent, and their inverse. Before then, we are forced to introduce one more or two more things, being 3 over 2 for division. And then you observe that in Python, 2 double slashes means integer division. In Matlab, there's nothing like that, unfortunately. Okay, so everything is seen as a real number. The multiplication is the star symbol for multiplication. So therefore, we move on to look at trigonometry. Now you have a fair idea about how to perform some basic arithmetics over here. The argument here is, how do you perform some functional activities like sine? Just as we all saw in our most likely our first year courses, then you realize that anytime we are writing a function, it's most likely to be written as a function f of a given input x. And this represents maybe a sine of x. You hardly will see us writing sine x this way. You hardly see it this way, but this way. In as much as you might be confused with this notation, it's good to note that from your algebra classes, function notations are written in this form, which means the function name, the curly braces, and a given input. So therefore, all functions in Matlab requires the name of the function and a curly brace. By the way, I am forced to let you know that the name or the word Matlab stands for Matrices Laboratory. Matrices Laboratory, which implies that if your fundamental concept in algebra, matrices, is not too good, then you may struggle a little bit at the initial stage, but it's not too late to recap the few things you learned in your year one and proceed from there. And again, we are saying year one because we are assuming that almost everyone here is still in education. Is still in education. That's the assumption on which we are making this assertion. If you are not, that is fine. Then the assertion is that you might have finished your first degree most likely and might have gone through these processes already. Okay, so sine. And note that if you use sine, cosine, and the rest, you are actually dealing with radians, not degree. So sine into bracket, maybe a number. Maybe a number. But then it's important to take you through. I can still skip that part and then come back to it later. Let's put in any number here, say 2, and hit enter. A number is being produced. So the key thing here is that the function followed by a bracket. Then you continue from there as well. In the same way we have cos into brackets, say a 3, cos 3. Here we are with a number as well. And a tan, which you all know is the ratio of the sine and cosine, which also means that they are asymptotes in tan when being sketched. So I put in the value, say 3, and gives me a number like this. Now, we all know that most likely from our high schools that it's also possible to reverse the operations of a trig function. And that's the inverse of it. And we all believe or we all know how to use composition to prove if a function is an inverse of a given, if a function f is an inverse to a function g through composition. But we are going to go through this process, and the argument here is that if indeed the inverse of this number exists, then it must give us the number 3. How do we find the inverse? We use the word arctan. Arctan, atan. So put in the value minus 0.1425. The same this failed to give us the input we are expecting, most likely because of truncations, which I'm not so sure about. So we have to investigate why that is giving us the answer we do not deserve. 0.9093. Okay. So again, issues of approximations are very critical over here. This seems to be getting closer to it. That is around 2, but of course, I can't convince you that it's 2 because it's not more than 5. But again, the issue of truncation now becomes an issue over here. And you should observe that very soon on how to address issues of precision in the first place. Okay, but the A tan, the A sine, the A cos stands for the inverse of the original functions sine, cosine, and tangent. Okay, so we proceed from there. For example, the exponent, exp, and then we pass in the number, say 4. So here we are. Logarithm. If you say log, this gives you natural log. That's log to the base e of a given number 23. There are a lot of such things out there. We can search through and see how it works and proceed from there. Okay, so again, we're only giving the basics, and they cannot zoom into the second series that looks at different ways of getting things done, real examples from engineering point of view, and try to solve them and see how it goes. Okay, so we proceed from there to look at what about log to the base 10? Log 10. So to be sure that we are on a safer path, I'll just say log 10 to the base 10. And so therefore you are convinced that log 10 will give us 1. Whereas log 100 is 10 to the power 2. And for the laws of logarithms, it should give us the number 2. Here we are. So you are convinced that indeed log stands for the ln, natural log, and this stands for the log to the base 10. As computer scientists here, then the log to the base 2 will be something important for you to kind of look into and see how it works as well. Okay, these are the few things about the trick upon adding a few things to it to pay attention to other built-in functions made available to you. Okay, so we continue from there. Now, complex numbers. This is more convenient for those who have a math background here as well as engineering background. They may be using these complex numbers a lot, and you know that for the complex domain, your imaginary part is denoted either with an I or a J. In the math world, it's mostly IJK, but in the Matlab world, it's I and J. So therefore, I can write, for example, 3, the real part of a complex number, plus the imaginary part, say 2i. So a complex number 3 plus 2, the real part, the imaginary part. So j is also allowed. But as you can see, I type in j, it converts them back into an I for me as well. However, you're not wrong to have typed j, but the notation is I understandable by Matlab. Okay, we won't be spending so much time on this. However, once it comes up in your field, it's easier to appreciate what they are and what they do. Okay. Now to special constants. Special constants. An example of a special constant is the pi symbol. I cannot put a pi as a symbol here. However, MATLAB has codified some of these things for us. One of them I type as pi, which stands for pi. And we know from high school that it's a value which approximates 2 × 7, resulting in a convenient number being 3.142. So here we are. But MATLAB always gives us a position of 4 decimal places by default. And how do we change it? These are a few things which I'll be learning as we proceed from there. So we thought 3.142 because the number 6 runs off to 1 to give us 2. Okay. The E as a constant. Okay, so I think E is no more functional over here again. So therefore, it should depend on the exponent and proceed from there as well. So again, at this point, we are forced to now tell you how to interpret errors. Once the red color comes in here, it tells you that you are doing something wrong. As scientists, as developers, as programmers, we are bound to face a number of these things, but we believe and appreciate that as they come up, it gives us an opportunity to know what is going wrong and address them as well and proceed from there accordingly. Okay, so it says that a function may be or a variable e is unknown to us, which then means that we are unable to use this. And as time goes on, we shall learn how to understand and appreciate some of these error terms as they come up. Okay, so at this point, then we are forced to end this part of the section to let you know that when it comes to Matlab, just as in any language, we have the basic operations in arithmetic, being the plus, minus, the multiplication, division, and the exponentiation. Okay, just as we know from our various high schools, the board mass principle, in some schools, the paired mass principle holds, where E stands for exponent to be treated first, followed by division and multiplication, which are on the same level, so first come, first serve, and addition and subtraction, again on the same level, first come, first serve. However, if you want to break the protocol of this ordering, then the P, the parenthesis, or the bracket is used to break the order in which they should be executed. Okay. And now you know how to do addition, subtraction, multiplication, division, and exponentiation in Matlab. So therefore, we look at the next basic and important concept being variables and arrays. Variables and arrays. As you can see, because you and I decided and chose not to give a variable to our expression, it ended up being nothing but an ans. And how do we avoid an ans and put in our own variable? At this point, it's important to know the nomenclature of a variable in Matlab. The first thing you must note is that variables in Matlab are case sensitive. So therefore, just equals 4, and then just equals 4 are two separate variables, as you can see in the workspace. Just 4, just 4. One is capital, one is small. So as a good practice, we always tell students to decide on which nomenclature you want to make use of to avoid ambiguity. If you are staying with lower cases, stay with them. If you are staying with upper cases, stay with them. But the good practice is to go lower cases for expressions and go upper cases for constants. Because we have engineers here, we are forced to use the word constant here as well, so they know how to declare them and proceed from there. I cannot start a variable with a number unless most likely the new MATLAB allows it, then I can be sure. So 3 just is equal to say 4. Then that's it. It tells me that this is an invalid expression. So I can't start with this. I can't also use special characters except underscore. Underscore. So just underscore ice. This is allowed. This allowed. Okay. So variables are nothing but symbolic names given to expressions and values. Okay. Again, a variable must start with a letter and any other thing can follow. So again, I can also have just 3 is equal to 8. And it's allowed. All what matters is that your first element or your first character should be a letter. Then you are good to go. So here we are. is case sensitive. So be very careful what you do. Now, you want to have a fair idea about your variables. You can either pay attention to the workspace here and observe their values. If you want more details, there's one keyword called the whos. Type whos, and then it gets displayed and tells you that, hey, I can see just as a variable name, a name over here. The size, the dimension of that just is 1 by 1, which means a scalar. It's an 8-byte scalar, and it is a double, what we call a real number. It's a double. We have an ans, a just 3, just i's, and they're all defined over here. This helps us understand what we have in there or what we still have in memory. So this is our memory, and the content of our memory is what we are seeing here. Again, at this point, I'm forced to jump the gun a little bit to speak about how to erase my memory and how to erase the content in my command window. So I do CLC, and that clears my command window. So everything is gone. Okay. Now, if I want to clear my memory, I type CLEAR, clear. This clears my internal memory. So take note of this as well. Okay, so we proceed from there. So whose gives me nothing. Gives me nothing. Okay. At this point, we are now forced to now learn how to input arrays, which you may end up calling a vector or a matrix. Okay, so we start. How then do we enter a vector? At this point, we are going to try the following. Y is equal to, we have tried y equals 4 scalar. Now, a list of numbers in a given order, say 4, 2, and 5, gives me a vector. And again, from our algebra class, we know that this vector, because they are in a row, there's only one row with multiple columns. They gives us a row vector. However, 4, 2, 5 has multiple rows, but a single column. This gives us a column vector. It's always the case. Okay. What do you observe here? A row is intersecting a column, and that gives us a value in the intersection. Another column, a value. Another column, a value. This means the number of intersections tells us the number of elements in a given vector or matrix. So therefore, a collection of these vectors becomes our matrix. So one vector, one vector, one vector gives us a matrix. One column vector, column vector, column vector, again, a matrix. We shall get there very soon and see how it works. Let's proceed from there. So how do we enter a vector in Matlab? So there are two ways of doing that. The first question is, what type of vector is it? Is it a row vector or a column vector? Okay, so we shall start with a row vector and see what happens over there. The values are 4, 2, 5, kept in y. So y is equal to square bracket to tell Matlab that you want to enter a matrix. Of course, a special matrix called a vector with values for space 2, space 5. The space simply means that you are building a row vector. A row vector. So I hit enter and it tells me, hey, I can see a row vector with elements 4, 2, 5. The order in which they appear matters. I can also enter the same thing, 4, 2, 5, but this time around, comma, 2, comma, 5. A comma or a space, they both denote a row vector. Okay, so now we know how to enter a row vector. If you're scripting, then you realize that you can't be typing things and be exposing the values over here. So you want to suppress. How do you suppress? Use semicolon to suppress. that says that, hey, I'll give you this number, but keep the number in your memory. Don't tell me what is inside. So it tells me that, well noted, I've kept in my memory 425, but I won't display it for you to see it. If you want to see it, type YY and then it will come out. It will come out. So take note of that. Of course, the video will be shared to us to go through them again. For a column vector, Z is equal to, now because we are saying that the numbers must follow on the next line, in that order, semicolon is being used. So 4, semicolon, 2, semicolon, and 5. To tell Matlab that this is a column vector. So 4, 2, 5. The order in which they appear matters. Take note of that. It's very essential. Okay, so here we are in Z 425. Again, I can choose to suppress it with semicolon at the end of the expression. Some also prefer to do the column entry like this, which I don't advise anyway, unless for a very big matrix. ZZ is equal to square bracket 4. Hit enter. Because Matlab has not seen the closing brace, it will demand for more values. So the prompt has vanished. So 2, enter, 5, enter, then square bracket. Once I hit enter, it tells me that I'm done. So again, 425. These are things I believe you must pay attention to make life a little bit easier for you. Okay, so you can keep noting that your questions. Will give you some time to express yourself, and then we will proceed from there as well. Okay. So I've taught you a row vector, a column vector, and then the next thing is a transpose. A transpose. If I transpose ZZ, and how do we do that? We use the prime symbol. So I'll just say the variable name, then prime, the apostrophe. Okay. So by doing prime on it and hit enter, you realize that U is equal to ZZ prime. This will not give me a row vector of 425. Here we are, 425. It's important to note on these things, especially in data science, where we have to transform our data from one state to the other state and proceed from there. So therefore, it comes in handy to know how to transpose your data and proceed from there. The field agent gave you a data for analysis, and the columns have become the rows, and the rows have become the column. You don't have to be angry with the agents. Just import and clean them up. Okay, so now we know how a transpose works. The next thing is there are other ways of building a vector without going through this stress. And when we do that? So, the last part says there are vectors we can create either with ranges or the linspace. With ranges or the linspace. And that's the next thing that you and I will want to pay attention to. Okay, so we start. But before I start, the question is, when do we use it? Use the range if and only if you know your start, you know your end, and the intervals of them are consistent. For example, 2, 4, 6, 8, 10. This is a sequence with a common difference of 2. So therefore, instead of typing all of this one by one to waste our time and resources, we use the range operator to achieve that. So all we need is to know our start, our end, and our increment or our step. Most books call it step or increment. So we start. And how do we tell the system to understand? Just say W is equal to start from 2, colon, increment by 2, colon, end at say 8. Hit enter. So here we are, 2, 4, 6, 8. What happens if I choose 9? Because after 8, the next number is 10, it will end at only 8. So here we are, 2, 4, 6, 8. 2, 4, 6, 8. This is only used if you have a start and an end and an equally spaced interval. Then you can do this. And you know how the spacing are being organized, then you can do this. But what if you know your start and your end, but you have no idea how the spacing looks like, but you know how many elements you need? This is when the lane space becomes important. Okay, at this point, I see a hand up. I'm forced to pause and then probably enable the speaker to speak. So, Williams.
Okay, sir, thank you. Um, I didn't want you to continue, move ahead, so that will bring us back. But what you just did, the 2:2:8, I didn't get that part.
Okay, that's fine. So let me repeat again. So all I said over here was, I know my start, I know where I will end, and I know how many steps I'm going to be taking at every point in time. So start from 2, take 2 steps and stop 4, take 2 steps and stop 6, take 2 steps and stop 8, take 2 steps and stop 10. I know how many steps to take and to stop. For that reason, we use the range operator, which is 2 colon 2 colon 8. My starting is 2, my steps are 2, my last value is 8. So 2 plus 2, 4, plus 2, 6, plus 2, 9, sorry, 8. Then I give another example here. Start from 2, end at 9. 2 plus 2, 4, plus 2, 6, plus 2, 8, plus 2 is 10. Is 10. And 10 goes beyond the limit in which we are supposed to work in. So therefore, it ends at 8. If this goes well, give a thumbs up, and then we continue from there as well. Okay. Now, what if I know my start? Thank you. What if I know my start? I know my end, but I don't know my steps. However, I know how many elements I need. So for example, start from 2, end at 10, but I want them to be partitioned into 10 pieces, or sorry, into 100 pieces, for example. 100 is too much, so 20 pieces. That I know. That I know. In image processing, in signal processing, we come across the word quantization. In your algebra, you come across the word discretization. So this is where it comes in. So start from 2, end at 10, but I want them in 20 pieces. This is where the lane space becomes important, which means that linearly spaced. And know in algebra, if you are linearly spaced, then your difference are consistent. Graphically, then your gradients are consistent. But we say your difference are consistent in the sense that we are assuming that the change of x is equal to 1, as opposed to change of y, not, which might be or not be equal to 1 from algebra. Okay, so lane space is a function. So just type lane space into brackets, starts from 2, end at 10. I want 20 pieces of such. So here we are. So start from 2, end at 10. And what do you see? At the end of the day, we have 20 elements from 1 to 8, 9 to 16, and then 17 to 20. So Matlab will take these two numbers, find their differences, divide by the total, which again we know from our basic algebra as x2 minus x1 all over n. This is equal to nothing but your step. So therefore, I pick my x1 plus my step to give me my next number until I get to x2. Okay. So we shall find these two very handy and very, very, very useful going forward very soon. Okay. So we proceed from there as well. So know when to use your range operator and know when to use your linspace. Of course, if the numbers are 2, 6, 4, 8, then I have no choice than to go with a square bracket because there's no shortcut to doing that. 2, then 6, then 4, then 8. There's no pattern. So therefore, we keep it in the square bracket notation. Okay. I think my board is now a bit nasty, so I'll just clear it by just typing CLC whilst keeping my memory intact. CLC, and here we are. Again, the video will be sent to your email at the end of the session. Okay. So we now come to the use of clear, which I've already taught you what they are. The next thing I want to take you through is, let's go into matrices first. I think I missed something here before I come to these operations. Okay. Let me see, there's a matrix here. Okay. There's one here, but we'll come back to it as well. All right. So before then, let's do some few matrices. Okay. So I see another hand up. Let me quickly. Okay. So you may continue.
Okay, so thank you. So I wanted to ask, in using the lens space, is there a way of getting integer values rather than doubles?
Thank you. If you observe carefully what I did here, then it's obvious that you cannot guarantee an integer space unless you know what you are doing. Because you are saying that I have no idea what my steps are. So, hey, Matlab, get me a step. All I care is that at the end of the day, I'm getting n values. N values. So you don't control the steps. Matlab control the steps based on how many entries you are looking at. Okay. So we proceed from there. I have two vectors put together. A is equal to 2, 4, 5, 7. How do we enter this in Matlab? In Matlab, we enter row by row. Even though I told you earlier on that two rows or multiple rows forms a matrix. Multiple columns also forms a matrix. In Matlab, the rule of thumb is on the rows. Is on the rows and not on the columns. So we enter row first. So a row is entered either with a space or a comma. The next line is entered through semicolon. So we are going to combine these two ideas and knowledge and continue from there. So capital A is equal to my first row, 2, 4. Then the next row is now semicolon. So I taught you how to define a column and how to define a row. So therefore 5, 7. I can also mix them 5 space 7. Matlab will understand that a space and a comma are all the same. So here we are, 2, 4, 5, 7. 2, 4, 5, 7. If we dare enter them 2, 5, 4, 7, so A is equal to 2, 5, 4, 7. Matlab will not give you what you want. It will give you 2, 5 as a row 1 and 4, 7 as row 2. So please, in Matlab, we enter row by row. We enter row by row. Just as we do in Python, but in Python, we use double brackets in doing that in Python. So take note of that as well. Okay. So I'm going to enter a number B, put 1 here. I hope it will not lead me to, yeah, it won't. So 6 here. So A is this and B is that. Okay. Now, once I go into this, then I'm forced to tell you this. If I want to add two matrices, A to B, just as we know, the size of A and B must be the same. So I'm going to put a C here as a row, 1, 6 as a row. So A plus B, they are conformable, which means A and B have the same size, so they can agree to add. Here we are. Subtraction can agree to add. Here we are. However, A plus C can't agree because C is 1 by 2. 1 by 2. That's the size. And the size of a matrix is defined by the rows and the columns. How many rows? How many columns? So you start from the row. So here, how many rows? There are 2. How many columns? There are 2. So therefore, 2 by 2 matrix. 2 by 2 matrix. So take note of that as well. Okay. So how do we know the size of a matrix in Matlab? This is where the word size will be used. Okay. So if I do A plus C, they can't agree. So it gives me, oh, there's something interesting here to pay attention to. I have an A. This is quite new to me in what Matlab is doing. So A is the value we are seeing here as 2547. And then we have a C being 2, 6. And honestly, I'll be unable to explain this thing because this is quite new in Matlab. And we all know from algebra that it's not possible to have happened because A and B, A and C must have the same size for it to work. So I may have to look at why it is working, and then we shall put in a footnote in the video to be shared as to why 4, 11, and then 6, 13 is the answer to A plus C, given that this is 2, 6. The only thing that may come to mind will be that MATLAB probably is duplicating the C to give us 2626. So let's assume that and do it over here. So C semicolon C. So CC, and let's do A plus D and see what happens. Interesting. So that's observation. So in the olden days with MATLAB, A plus C is an error. In fact, in algebra, A plus C is an error. But in MATLAB, it is possible, as we all can see now. In MATLAB, it duplicates the value with its own intentions and it gives you an addition instead of an error. So it's now rectified. So let's continue from there. Okay. This means that the choice of algebra here is not applicable as well. Okay. So we proceed. Now, if I do A times B, here we are. This is called the matrix multiplication. The matrix multiplication, where the rule says that if I have 2, 4, 5, 7, and have a B, say 1, 1, 2, 1, then the rule says multiply this to occupy your first element in C. This to this for the second element here, this to this third element here, and this to this fourth element here. Since we are not here to teach algebra, I will not spend time doing this in this session. But in subsequent series, MATLAB for algebra, MATLAB for numerical methods, MATLAB for differential equations, and the likes, then we shall be doing some of these things over there. But the intention here is that we want to multiply 2 to 1, 4 to 2, which is very common in image processing or the image algebra. This is called the element-wise multiplication. And only 3 operators obeys that principle: the division sign, the multiplication sign, and the exponentiation. So it's called the dot operation or the element-wise operation. The element-wise operation or operator. So what do we see here? So here, I want to multiply A to B. Let's call that our A again. Call that our B again. Here we are. So 2 times 1, 5 times 5, 4 times 4, 7 times 6. So A dot star B. So here we are. 2 times 2 is 4. But in terms of matrix algebra, it is 2 times 1 plus 5 times 4. So 5 2, 20. 5 4, 20. 20 plus 2, 1, 2, 22. So here we are, 22. But here is 2 times 1, 2. So this is how we do it. The choice of this over this depends on the application you are dealing with and how to seek to achieve based on the practice. Okay, so you continue from there. Now, division will now give us A dot divide B. So we shall divide 2 by 1, 5 by 5, 4 by 4, 7 by 6. So here we are. 2 by 1 is 2, 5 by 5 is 1, 4 by 4 is 1, and then 7 by 6 is this. And finally, 2 to the power, a to the power 2. This means square individual elements and continue from there. So here we have the following: 2 squared, 5 squared, 4 squared, 7 squared. So this is called the dot notation, the dot operation, the element-wise operation. Okay. So therefore, how then do we access elements of a given array in the first place? To know the element of an array, always ask yourself which positions are they. So for example, in A, here's A for us. I want the element 2. You ask yourself, which row are you? Which column are you? Is found in, use a bracket to do so. In Python, it's called a slicing, the slicing. So A, 1, 1 will give me the number 2. A 1, 2 will give me the number 5. Row 1, column 2. Row 2, column 2 is 7. Okay, so under hand up. Opokun, continue.
Please, I want to ask for the dot operators, does the sign with two matrices has to be the same?
Thank you. Thank you. As far as algebra is concerned, the answer is yes. But since you have asked, let's try it on A and C and see if it's an error or it's allowed in the current Matlab. So as you can see, it's allowed, all because, again, behind the scene, it has duplicated the C, which means that whichever is bigger will be transformed onto the other. For example, A is bigger than C. An argument here will be, what about C dot star A? Will C times A become a 2 by 2 or to be 1 by 2? This is a question of interest to us. So let's hit enter and see if A will be reduced or C will be increased. So as you can see, in Matlab point of view, the biggest matrix is the benchmark or the baseline for a small matrix to adjust. The C was 1 by 2. The C was 1 by 2. The A is 2 by 2. So therefore, C is forced to become 2 by 2 to work with it. Okay, so Williams.
Yeah, so I wanted to ask in actual algebra where you're adding two matrices and they are of an equal size. So where you don't have an element, we assume over there is zero. But in this sense, since Matlab is duplicating it, won't that affect the result you get?
Thank you. As I said earlier on, as far as our algebra has not changed, you can only add two elements if and only if they are the same size. So you must take note of that. Unless maybe there's a new algebra I'm not privy to, then the math guys here may want to speak to it. But as far as I'm concerned, from algebra point of view, the matrix must be of the same size to be added. So Matlab is trying to avoid an error and assuming for you. So thank God it's a language and we have to obey the language and know when to do what we are doing. So don't assume that Matlab will give you an error going forward, but instead note that Matlab is assuming for you duplications. This implies that if you have 2 4 2 4 2 4 2 4 2 4 like 10 times, don't waste your time typing 2 4 10 times. Instead, just type 2 4 and Matlab will add the rest during the computation. But again, be extremely sure of what you are trying to achieve before you do so. This is the angle or this is the response we are getting from Matlab and learn the language accordingly and proceeding from there. As I told you earlier on, in the older matrices, in the older Matlab, this will give you an error. In fact, in the various books I'm using for the class, this also gives an error per their book. But per the new Matlab from 2020, I have 2024, so 2022 upward, we should expect the behavior to be the same as well, unfortunately. Okay, so how then do we, okay, so let's go back to our initial thing, our A. How then do I pick the number 2 and 5? The number 2 and 5. Remember that we have to define which row we find ourselves, that's row 1. And which column are we? We want both column 1 and 2. So, comma, 1, comma 2. Note the square bracket put over there. So, enter, it gives us 2, 5. I want the second row. I put 2 there. Row 2, column 1 and 2. I get this. I want the number to be 5 and 2. I want row 1, but I want 5 first before 2. So I'll have to change the location of 2 and 1 here. So 2 and 1. So it gives me 7 and 4 instead of 4 and 7. For row 1, I get 5 and 2 instead of 2 and 5. Okay. Sorry. Because I want every column in row 1, Matlab says, hey, I have an easy way for you to do that, which is semicolon. Semicolon. So that's the use of a colon. Semicolon. To tell Matlab that I want everything in my column in row 1. So here we are. Here we are. I want everything in my first, all the rows in the second column. All the rows in the second column. That gives me, from A point of view, 5 and 7. 5 and 7. So here we are, 5 and 7. All the rows. So the column there stands for all. It depends on where it is. If it's found in the row column, in the row space, it becomes all rows. If it's found in the second part, it becomes all columns. So take note of these operations. There's one more thing to pay attention to, again, about accessing matrices. We don't want to overwhelm with so many things. Just the basics, and then the next series we'll be adding on to it slowly till we get there. So the last thing is, I want row 1, all the rows in the last column, I don't know what the last column is. And I don't care to know what the last column is. All I want is the last column. Because I don't care to know what the last column is, the word end is used. The word end is, which means the last. So all the row in the last column is 5, 7. So enter. Here we are, 5, 7. However, if I do, and some of you will be doing machine learning, for example, in my class, this is a very common thing where all the elements are put together. So how do you separate them? And again, in the field of image processing, those who are interested, when we get there, we shall see how Matlab can transform our lives in appreciating those things. Okay. And again, it will always remain free to join if and only if you are interested, just to learn and proceed from there as well. And do well to follow our LinkedIn profile to be able to get access to this information put out there all the time. Okay, so if I do A into bracket end, comma, end, at this point, we are saying that I want the last row, the last column as an element. Don't forget the word end here is a number, which stands for how many. So here is found in the second compartment. So it's asked a question of how many columns. The number is 2. So it becomes this. Here, how many rows is 2. How many columns is 2. So we are referring to A2, 2. This guy. A2, 2. And that is 7. So here we are. 7. Okay, the more we practice, the more we are able to appreciate what is happening. Now, assuming you're in the industry and someone gives you a large matrix, you can't spend time going through one by one. At the same time, you want to have a fair idea about what is inside. So the function size becomes prominent. Size of A, it tell me how many rows and how many columns. We all know that this is a 2 by 2 matrix. So you expect 2, 2. So 2 by 2 matrix. If I want to ask, I hope that also works. How many rows do you have is 1. That gives me 2. And how many columns do you have is 2. It also gives me 2. So take note of some of these things in the first place as we proceed to looking at other stuffs as well. Okay. So we proceed to looking at another important thing here and see how it works. A variable, say A, but I see 4 here, so I must use maybe a 4 by 4 matrix to demonstrate, or 5 by 5. The default variable is always called an ans. It's already clear to all of us. So let's clear our page, and then let's choose a big matrix. I want to just use the magic function to do that. 5 by 5. Oh, sorry. Only one argument is allowed. 5 by 5. 5 by 5. Going forward, I shall explain to you the meaning of the magic function and what it does. Okay. But if you care to know, you observe that if you add all the numbers here, the answer you get is the same number you get here, the same here, the same there, the same here. At the same time, the same here, column-wise, they are all the same. So it's called a magic number. Okay. So A into bracket 2, 3, 2, 4. 2, 3, 2, 4. Okay. I would have wished to ask you that question for an answer, but given that we don't have that luxury of time, and given having 30 more minutes, I'm forced to take us through and proceed. So how do we explain or interpret this? Don't forget the first part is in brackets. The last part is in brackets as well. And you all know that the first guy stands for our row. The last guy stands for our column. If that's the case, then all we are saying is that I want column 1, column 2, what am I saying column? Sorry. I want row 2 and row 3 to be called out. So row 2 and row 3 to be called out, which means all these guys will be thrown away. When we are done, then we ask ourselves, column 2, this guy, 5 and 6, and column 4, 14 and 20. That's the meaning of this expression over here. So first, deal the row. When you are done, deal the columns. So the answer should be 5, 6, 14, 20. So 5, 6, 14, 20, 14, 20. So take note of that as well. Okay. So we proceed from there. All this, if you go into a typical Matlab book, all what you have done is called the sub-array. The sub-array. Or array manipulations. At this point, I'm forced to tell you one more thing here and then we'll continue. Assuming I want to replace these values with something else, I'll just call it back and say equal to, then I'll pass in the value 10, 41, 21, 19, 22. The size of the things you are pulling out must be equal to what you are bringing on board. So it means that the 5 here must be replaced with 10, 14 here must be replaced with 21, 19 here, 6 here by 19, and then 20 here by 22. So hit enter. How come how is 6 over there? Anyway, so hit enter. Here we are. 10, 19, 21, 22 shown over here as well. What if I want to delete all this column because I don't need it? Just ask yourself, what column is that? So all the rows will be out in a given last column. That's the end. Or I can just put the number 5 there. It's equal to square brackets. You can only delete an entire row or an entire column, but not some. So if I hit enter, all these guys will leave. And my new A is now this. My new A is now this. This is how to delete. This is how to add or edit a given field. Okay. So that's what we have over here for you. Then we now move on to another important and interesting concept called systems of linear equations. Systems of linear equations. Again, in your numerical method class, in your algebra class, or let's go back to our high schools. In our high school, we came across what we call the simultaneous equation. The simultaneous equation. This so-called simultaneous equation is the same as what we call the systems of equation. The systems of equation. But here, we are ensuring that the highest degree is 1. So it becomes the systems of linear equation. An example is 2x plus 4y plus 7. Since an equation equals 0, you have to be sure that it's not going to be singular. So 3x plus 7y minus 6 equals 0. This is the equation we normally will get from high school. And the argument will be that solve for x and y. Solve for x and y. This is a simultaneous equation. Strictly 2 equations. And this equation has to be written in the form ax equals b to make it compatible for Matlab to operate. So it becomes 2x plus 4y equals minus 7. And then if you are here in level 200 from University of Ghana, note that these are things we shall be doing this semester. If you're from another institution, you might have come across this already, most likely. If you are beyond year 2, again, you might have known some of these things already. If you have engineering background, maths background, CS background, you might have gone through this as well. If not, it's a chance to also learn and continue from there. So here we are. So now this gives us, in a way, we aren't there yet. In a way, AX equals B. Here is our B now. Here's our equal to sign now. However, we need to now change this whole thing here into what we call the matrix representation. So what do? We pull out our A, and the A is a matrix. So 2, 4, the coefficients. A multiplied by X, Y. XY is equal to minus 7, 6. This then give us A, and all of this is called X, is called B. This is called the matrix representation of a system. At this point, we can now solve. Remember that in the previous slides, I never mentioned to you division sign, unless dot division, which is possible. But we cannot divide two matrices, A over B, from algebra point of view. However, this is possible if and only if we are saying that A times 1 over B, which gives us A times the B inverse. So you can find A times its inverse is the same as saying A over B. Okay. Now, let's observe something critical over here. I have AX equals B. We are going to solve. From high school, they'll say find X and Y. So you just go through elimination processes to get the answer. In the university, it's called, we have several types, but the common one is called the Gaussian elimination or the Gauss-Jordan method. We shall see all of this if you are second year in the University of Ghana. Okay, so if I have AX equals B, then ultimately I'm looking for my X. So therefore, I'm forced to say X is equal to B over A. And clearly, we can't do something like this. We can't divide a vector by a matrix. Even though I'm being cautious with the word you can't divide, because in Matlab can do it. But I'm speaking from a pure math point of view. So therefore, what then do we see in the first place? Well, we are clear at the end of the day, there are two numbers expected. So it becomes B, and then you realize that this guy is under the A. So the inverse of A, and continue. However, Matlab is generous enough to give us the backslash operator, which is used for performing the inversion method in computing the inverse of a given matrix. So all you do is you just write B /A, B /A, and then you are kind of good to go. Okay. Now we know the representation. How then do we proceed from there? How do you proceed from there? Oh, I think this shouldn't work. If I'm writing, and the meaning of this guy here is B over A, which is not possible. So rather turn it into A and let this guy lie on it as B. Like it's kind of like we are turning this guy upside down, or we are flipping left, right. To become the matrix / the B. Okay. And that gives us the solution to the matrix. So let's clear our interface. A is equal to, now we ask what A is, 2437. 2437. I'm used to the comma than the space, so bear with me. And then B is equal to a column vector that's -7 and 6. -7 and 6. One may say that I'm wrong because this will give me a row vector. So I'll just put a transpose on top, and that becomes -7 and 6. Without this guy, it's a row vector, so take note of that as well. Okay, so now my x is equal to nothing but a backslash b. A backslash b. Once I hit the enter, it tells me my answer is, the first answer being my x over here is -36.5. The second answer being 16.5. We shall observe how to sort some of these things in the other series. But how convinced am I that this answer is correct? That is confirmation of solution. To do so, note that it was ax equals b. So we just say a times x because we have x in memory. So therefore, that becomes nothing but -7 and 6 with some approximations. So here we are, -7 and 6. -7 and 6. This tells us that the answer given to us by Matlab is indeed correct in the first place. Okay, so that's how to solve a system of equation. Of course, what I've taught you here has several pitfalls from numerical methods point of view. In other series, Matlab for numerical methods, we shall learn those pitfalls and how to resolve the pitfalls through Gaussian with partial pivoting or complete pivoting. Okay, so that brings us to the end of the first section. They will now move on to looking at plotting and graphs. Plotting and graphs, which might probably be the last thing to look at. And we shall now defer the programming part to the second series, most likely. Okay, so how then do we plot? We have 2D plot and also the 3D plot. The 2D plot and the 3D plot. We shall start with the 2D plot. And what do we want to plot? We want to plot this guy over here, or this function over here, taking on values from 0 to 20 inclusive with a step of 0.2. Once our step is known, then it's obvious that the column notation will be relevant. So we start. Let's click. As we click, we now begin to pull out our, don't forget, Matlab is procedural. So I cannot type this guy first before this. However, that is possible through what we call the handle, the function handle, which will be treated in a second series. Symbolic equations. So here we start with our x. X equals nothing but our start being 0 and a step of 0.2 and an end of 20. Because we know what it's about, to be a waste of time to open it up. So let's press and run. So here's our x. You can always go into your x here and observe the size. This gives us 1/101 doubles. Okay, now we have something over here. Let us now type out our y. So y is equal to then the expression. This is where you must be careful. Don't forget, we are reading this guy to a vector. So therefore, we must make use of the various notations that we've been taught of. So let's start. But the good news is that these functions have been programmed to understand vectors as well. So no more stress for us. So exp minus a given variable x divided by the number 10 multiplied by the sign of a given number x. X. Here we are. Again, we suppressed the answer. Something is missing. Okay, good. As you can see, we are multiplying a vector to a vector, which is not possible without having a dot over here. So dot multiplication. Does the error even tells us something like that? Yes. So it says use the dot times instead of the normal multiplication here, all because the dimension don't agree. So enter. So we have our y. If you check your y here, you observe that the size of y is also 101, just as x. So therefore, we can leverage on the basic plot function and just say plot x comma y. Plot x comma y. So here we are. So I'll just click on run, and then a figure window will appear. So here we are, the figure window. When it comes to the latest versions of Matlab, you will see all these animations down there as well. The 3D version, how to pan on a 2D, if you are doing, for example, signal processing, and then how to scroll and zoom into a given page. But we don't need these things at the moment. So therefore, we proceed from there and see what is next for us as we begin to wrap up for the first series of our journey. Okay, so based on your feedback, we shall know when else to activate the second series and proceed from there. So pay attention to your emails. We shall send you a feedback form. Tell us what you think about this journey, and then we shall see how best to improve if your expectations are not being met. But again, remember, it's the fundamental thing we are trying to put across for you. Okay, and we believe that with this fundamental knowledge, you can extend your knowledge from there and proceed from there as well. So it's called a figure window with some graph shown over here that tells us probably a bouncing ball. And from algebra point of view, this could be a geometric series, a geometric sequence, sorry, being produced for us. Okay. Now, how then do you observe? You realize that this graph has no lines in them. So just come here and say grid on, enter. Then you can see some small square boxes over here. If I say grid off, it also go off as well. So we want the grid to be on. It looks quite nicer. So grid on, here we have the grid. It's a common practice that anytime you are plotting a graph, you must put labels on them. How do you do that? Just type title into brackets, DISAL webinar. Hit enter, and you can see it appearing here nicely as DISAL webinar. Label our x-axis, x labeled, the x-axis as a string, the x-axis, or let's even say time, because it's more like a bouncing ball, time. So over time, the height of the ball reduces. So y label will be the height. So here's our height, also nicely labeled. Assuming I want to put on I want to put another function over here without letting this guy go or vanish, all I'll say is hold on for more figure to be added. If you fail to do hold on and you plot, this will vanish and a new one will come in. Okay, so let's hold on and let's plot z is equal to cos the same thing, but this time around using the cos. And then change our y to z. And I'll say that plot xz. Okay, again, the video will be shared with you to play back if you miss anything in there. or feel free, raise your hand, and then we'll try our best to repeat some of the things again for you. Okay, so that's the red one. Without you telling me what the red is and what the green is, I cannot tell what's happening. So a legend is important. The first graph we plotted was the Y graph. So I'll just put over here the Y graph since we don't have anything to write. The Y graph followed by the order in which you type is very key. The Z graph. So here we are with a legend appearing over here. That tells us that the red color is actually our Z graph. The blue color is actually our Y graph. Okay. So you now know hold on, grid on, X label, Y label, the title, and the legend. The next thing is how to manipulate the colors of your graph called the LCM. The line, the color, the markers. The line, the color, the markers. So here I shall type before you the following. Before then I'll say hold off so that any new graph I type will fill the space over there. I will plot the same Y, but the next thing I'll add is the LCM. So in quotes, we have the line. The line, we have a dash line. We have a dot line. But since it's a dash line, it's a dash line. Put your mouse over, you see a hover, and then some things will be showing as a value. Here they are, okay. So I want to use a dash dot line followed by a color. For the colors, the first basic is the blue, that is B, followed by, okay, not followed by, but the fundamental one is the blue being B, we have red being R, we have black being K, we have yellow being Y, and so on and so forth. Magenta being M, cyan being C, and so on. So the characters are distinct. So I put over here green, even though you cannot see very well from the screen. That is Jane. And then the last one is M, the marker. The marker. For the marker, we have the star. The star, which will be the star over here, the diamond, the square, and so on. So if I hit enter, you'll now see a green line with some small stars in there, and then some lines. It's not straight line, it's a line dot. So it goes like this. It goes like this, dot, like this, dot, like this, dot. That's a dash dot. A dash dot. This is called a marker. So marker, color, line. Okay. So the resource I'll be sharing with you contains all of that as well to pay attention to as well. Okay. There's one more thing here for us to pay attention to, how to import from external sources. To do so, what I do most often is to just type a variable, say dd is equal to 0. Then I have my dd over here. Then I'll now open it up. Okay. Open it up. Then this Excel part shows within this space. Then I'll now go and copy my Excel file. I hope I have an example here to just copy it. Just copy it and come and dump it. But remember, if you are dumping, there must be of numbers only, or there must be of a given numeric structure only. Otherwise, it won't work for you. This is something you must pay attention to. So this is how to expose your spreadsheets and put in values. So just copy and dump it. Don't come and type one by one here. Comma, semicolon. That's a waste of time and resources. So just come here, open it up, and then copy and paste them in and continue from there as well. This is called the variable editor. The variable editor. So this is the one for the X. As you can see, there are numbers over here. which you can even manipulate if you want to manipulate them. Okay. So that is how the variable editor looks like. So you can always import. And there are several importing strategies. How to import from the website and so on and so forth, which we are keeping into the advanced session. Okay. The next important thing you want to pay attention to is the subplot. The subplot. I want to plot two graphs, but I don't want them to be on each other. Instead, I want to plot one here, one there. This is called a subplot. One big graph, but being partitioned into spaces and then continue from there. To do so, subplot is being used. Subplot is being used. And how do we do a subplot? Before you do a subplot, you must first plan what you want to draw. Here, I have two graphs to draw, the Y graph, the Z graph. Two, after knowing how many graphs, how do I want to organize them? This way or that way? So you must plan what you want to draw. Because it's two graphs, it's always preferable, not mandatory, to plot them in two tiles like this to save space if you want to copy into your thesis or into your project. So we have our X and Y, X and Z already declared. So therefore, to plan your plot, you just use subplot. It's a function. So bracket. How many rows do we need? One row. How many columns do we need? Two columns. Which place do you want to plot? The first place. So I'll do this and declare my space. So I have declared the space over here. As you can see, there's a small white here and all this part is gray out. So at this point, I now say plot your Z over there. Plot your Y over there, sorry. Plot the Y over there. So I've plotted. Then perform all the things you want to do. Your table, your legend, all the stuff. Add them over there immediately. So the labels in time. If you don't do so and you continue, you are forced to come back again and do it. And then here we are. I can do a hold on and plot more over here before I continue. But the whole idea is I want to plot one here, plot the other one there. Sorry. The label, that's the webinar for Y. So here we are. Then I now continue to plot, to activate my second window, 2. So here my second window. And then I plot in there my Z. And I'll do it this way and change the color. So here I am with my Z. And again, I'll just call my time here. You can see the time is appearing here, not here anymore, rather here. Call my Y. Here's my Y. And call my legend, so my title, and put a Z there. So here we are. I'll perform a subplot for myself. Okay. The next thing is our curve fitting. Which is the polynomial fitting and their evaluation. Remember that in our various high schools, again, we are asked to plot some scatter plots. When we are done, we are told to put in the line of best fit. This idea of line of best fit is called a curve fitting. The curve fitting. We are fitting a curve to this. And we know from high school that is equal to y equals ms plus c. So our degree is 1. Let's go in here and begin to perform something small in that dimension, then wrap up for the day in the next 7 minutes. We'll be wrapping up exactly 7 o'clock. We have to end the section without taking extra time from you. Okay. I have a given x. I'm going to put in maybe a given y, probably. So y is equal to 2x 2 times x plus 9. Observe carefully what I'm going to get here. So I have my y here. I can choose to plot this guy and see what happens. Okay, so let me close this guide and plot my x, y, but I want only the markers, just the markers, so star. Here we are. As you can see, it's near a straight line already. Okay, so let's close and say that CC is equal to the polyfit, which means a polynomial fit. What is my x as? Is my x value or my x data? My y data is y. The order of my polynomial, I'm assuming, is 1. That's a linear equation. If I hit enter, remember that in high school, the answer we need is a value for m and a value for c. These are the coefficients you are interested in, or the parameters you are interested in. Okay, so then we proceed to see enter. So here we are. So therefore, this is my m, this is my c. And it's obvious that this is our m, this is our c. This is our c. So therefore, I can now say that perform a polynomial evaluation, which will not evaluate my new data for me. This is very important if you go to the field, collect data, and want to know whether there's a correlation between the two variables. Then it becomes important to do this through your Excel, being uploaded to the spreadsheet locally here. Okay, so that's what this guy does for us. And the same concept is being used for the 3D plot. And we have only 4 minutes left, and I think it's a good time to pause over here and possibly ask for some few questions. I will enable the entire room for speaking, and then if there are any questions you want to put across, you do so, and then we'll be glad to respond to you. So let me quickly. Okay, so I think once you are ready to ask a question, raise your hand, and then we'll be glad to respond to it. So this is what we shall move to our second series and then see how far. Okay, that's fine. Yeah. So this is what we shall now move to the second series to look at the 3D plotting, how to script in functions, making the programming bit of it. But again, this file we share with you anyway to go through them, and then based on your input, based on your questions, then we'll be able to respond to them accordingly, and then decide for ourselves when our second series will be to end up with the programming part of it. And again, there are 5 main series for the intro part, and then we'll continue to the 9th series before the year ends. And this happens every year, but it's the first time we are rolling them out for you guys or for everyone to participate in it. If you want to get to us, these are social media contacts to reach us at any time, from anywhere, in any time zone, and we'll be glad to respond to you when you call on us. The resource used for this session is sent from these two PDFs. So you can download it and begin to do some few things if it's taking too much time to wait for a second series. But we promise you that there will be a second series to continue with the scripting part of it. So any question to end today's series?